Testing 1 2 1 2. We're in the Ampere studio. All right. So I got this concept done, which I'd like to show right here. So we're gonna do some 3D modeling, but first, some measuring of light components. I have some pieces here that I could possibly use for the light, as well as ones that I purchased from the wonderful people at World Lighting in Farmingdale, right? So I have some E12 sockets. I'm a little twisted up here, but I have some E12 sockets with a candelabra bulb and some fittings as well. Which I could possibly use in the design. Alright. So these are the 40 watt 100 volt bulbs. So these would go right into there. Alright, so I could do something like that. Alright, so if we have this here, I gotta make space. This is actually pretty big. I think I want to stick with the E12 sockets because I don't want to take up too much space on the frosted shade there, right? So let me take some measurements. Let's get this real quick. Right. So with any design process, you want to be able to know the components that you're using. So for this, I just want to know if I'm going to use this socket. I need to know the diameter, and I need to know the length, because I'm going to 3D model up everything. And I'm going to use my trusty calipers to go through that. Zero them out. Okay. So for this here, a little square part, the 0.7445 inches. At the hex, so that's just at the hex there, and then the actual, because I could use that little bump there, the tolerance to fit that in there, because it looks like that will go straight through to the, without interfering with that bracket. So 0.731 is the 0.731 is the circle diameter. Then we're going to do the length here of that socket, which is about 1.7 inches long. So for 1.7 for the overall length, let's see, 1.2, 1.22, 1.22 base length. So the overall length of the bulb, I think I could get that in there with this bulb. Now, let's say 4.8. 4.8 overall length. Bulb. But what's going to happen here? All right, so I've put that in fully. Okay, good. So from the socket, let's say 3.22. Let's just go 3.25. 3.25 is what the bulb sticks out from the socket. Okay. So, I don't know what that thread is there. It's a 1/4 inch. This I could find out online. So 1.38. So this threaded rod goes here. So even with an actual socket, put those through there, and then this threaded rod will go in to that base there. All right, and then I just put, I wonder if these will work, a little bushing. Oh, nice. All right. So these were, I purchased these years ago. Purchased these years ago, and I still have the little bushing that goes on the back. This is great. Alright. Nice. This is the E26 lamp base, right? So I'm pretty sure this will work. Because most of this stuff is standardized, right? So if I just put this guy on there, yep, nice. So really all I need to worry about is this right here. It's great. And then put a little bushing on the back. I could get the one. Alright. And you just tighten that up. And I could probably get a shorter. Oh. I think I misthreaded it. Oh, it's stuck. Great. Okay. Alright, so I just want a smaller version of this for the overall design, because for that to kind of stick through all the way, not too appealing, right? You could always get a cap, kind of come down from the top. Yeah. Go down from the top there. But this is basically what I need. And then I have this version right here. This is the E26, which I can also use. Yeah, that's... Ugh. But let's make a design with this first. We can do that one later. So we're going to base the design around this rod now when we go into the CAD. So all I need is this diameter. Which I think I did. 0.38. So that's just over 3/8 long. So 0.3835. So what we're gonna do 0.383. And we'll just give it some space from there. I think I'm good on the measuring. That's basically all I needed for measuring things up. I got my cord, so I have a little wire here, black. It's a white one, but that'll do. All right, time to turn on the lights and get started 3D modeling. Cool. Okay, so I had some bad ideas. I'm not sure how I'm gonna get the cord with the plug to go through everything and not interfere with the design. Right, it's because I need to fit the plug through the hole. All right, and then with the threaded rod have a bushing on the back, but the bushings are, yeah, even this guy. Well, I had something like this for the E. I could use that. Yeah, I could use something like this, right? Put that on the back. Yeah. So for the light, I would have this go into there, right? And then thread, right? Because this is, yeah, this is wider. So thread that. So on the aluminum plate right there, I would need a bigger hole. So this is going to cover up the back, how big that hole is. So I will have hole go through, and then this sit like that, and then with the bushing, thread the bushing through the plate. So that would be a little cumbersome, but it will effectively wedge that into in between the aluminum plate and the acrylic part. So I'm going to go with something like this. Now I'm gonna get started 3D modeling because I want to get something put together today. It should be fun, shouldn't be too bad. I already started something up, but I'm debating whether I go the quick route, make everything in Onshape, and then export the plans, or do everything in Autodesk Fusion360, which I haven't used since like my first job, but I have a subscription now, and I'm gonna work on building 3D models within that platform, so it's all put together, not on the cloud until, because I use Onshape for work, but I personally use Fusion360 because it's pretty, it's okay. All right, so I'm gonna get started 3D modeling the monster light, and there's definitely gonna be some changes when I get to the 3D modeling, so we'll see how that goes. All right, cool beans. Testing, 1, 2, 3. All right, we are good to go. So now we're gonna get started in 3D modeling. 3D model our monster stand. I already got started here with a simple mock-up, because from the initial design here, I don't think it'll work really. So first thing here, I want to go onto the sketch. I'm gonna put a hole right there. So always want to show the sketch, and I'm gonna put a little hole inside of the part. All right, so I took my measurements and the raw diameter. So actually, I have to measure this little cap because we're going to use the cap. So just under that. Would help if I put the calipers on. All right. 1.4675. So we're going to do 1.3 and just make sure, well, actually, how big is this? 0.95. Okay. So we're going to make a 1.25 hole. Okay. Simple enough. There. Okay. So we have the hole. Now, one thing I haven't worked on a lot is I don't know the shortcut for this because we just have that look at, right? But we're gonna make a sketch on here for the lampshade. Okay, press L for line, and I like following the construction lines on Fusion 360 as well as any CAD platform. It just makes everything a lot easier. So what we did, we took our measurements for the E12, the overall bulb length and socket is 4.85. So probably want to make this at least 6.5 inches. 6.75 sounds good. Actually, 7 overall. 7 overall inches. And the height, I don't care too much about the height, but we're gonna go with six for now. One thing here that's really quick and easy to do with Fusion 360 is the snap tool, well, the project tool. So I want to project this line here, and then project that line, press OK, and then make this parallel to that. Constraint already applied. Okay, good. Now go back to the side, and we're going to project the top here, and then project this top edge. Just that. The thing I really don't like about Fusion is you can't do 0, right? So if I press 0 inches, because I want them to be essentially collinear, it doesn't do it. You could do it in Onshape, but not in this. So we're gonna just make that actually 0.125. 0.125, and again here, you know, we're gonna where's that line? 0.03. 0.03 is like a standard fit for there. So it kind of sits right above the base. And this is really big. 6.5. And 5 inches. That is a little bit more comfortable. So what I'm gonna do is make a flange. Let's see if we could do this here. No. So I'm gonna extrude the body. Oh, another thing. That's 4 inches. This I want to check. Okay. So I have my Ornery-Ox iPhone stand, and I want to see if I could take some, but no, not really. Can't really take any width off of that. Sometimes you just get it right the first time. It's very tough. It's very tough. All right, so that's, but that is 3.5. That's good. Okay, so we can decrease the width of this sheet metal part here because it was originally too wide. So it's 4 inches. Now we're going to do, well, another thing with Fusion 360, it's symmetrical, okay? Why, if it's symmetrical, do I put half the measurement? Don't you want, if it's symmetrical, the overall width? So now I have to do 1.75 because it, you know, doubles. You have to double your width, which just makes you do more math, and it's kind of annoying throughout the day. But we're okay with doing math. At least, you know, simple math. So here again, right? Distance, I want symmetrical, right? Here, 3.5. So the overall width. Again, I got to do this math. It's making you do math. So overall width is 7 inches, which that is a good width. I like that. Now, what I'm gonna do here is cut it because I want a slope. I want to give the lampshade a slope on the sides. So I'm going to create a sketch on this face, line, center this. Here, X is to make a construction line. All right. Then, yeah, 1.75. Okay. All right, pause. Okay, back in business. So, right here, 1.75 plus 1.25. There we go. Okay, so we're gonna mirror this line. And we can simply cut that. So here, go to E for extrude. As always, cut that. Do I like that? Man. I don't know. I don't like that. I like this version. I don't even know why I went with this angle version. I'll be fine. So yeah, we're gonna go with the original concept. Let's suppress that. I do not like that at all. So here we're gonna go 90. Oh gosh, we have to fake a line here. And make this collinear. But I do need an angle. No, I don't really. We'll see how this turns out. I'm just gonna go ahead and go with that. But in terms of how this will look, and if we're just gonna go straight up, how much space is in between? We have about about 6 inches from I'm gonna go with the nice little 7. So 7, no, 6 from the bottom. So I want the lampshade to be 6 inches from the bottom. Then I'll go 4 inches up. That's really tall. Okay. 16. Yeah, 16 inches tall. We'll go with 16. Just add 2 more. $16 by 7. Yeah. Make this collinear. Okay. Then I'll just dimension that. Okay. This does not need to be that thick. I'm just fussing around with some numbers, really. 0.25. But here's my issue. Here's my issue with this design. If I make it angled, I can just fix the front of this whole top piece. I don't even need that little lip there, that flange. I don't even need this flange if I just angle it there. All right. So 6 inches back. I gotta do that. Undo. So always make sure to dimension everything right. Inspect to make sure this is still the same size. So 3.5, good. All right. Another thing I dislike about Fusion is their dimensioning, right? So the coincidence stuff, it's hard to get used to, but it's all, you know, a process. I'm having a tough time making a decision here. It's just straight up simple. Yeah, I'm gonna try this one. All right. So we're gonna see how this looks with an angled shade, as I was doing before. But we're gonna just go and so project. So now I'm just kind of repeating things. But oh, here, that's really upsetting. That's upsetting. So another glitch, you know, you can't do a zero angle. What is that? Why can't I do a zero angle? What if I want to change it over time from 0 to 1? I have to do a parallel to make this fit. All right, okay. And then I can dimension it to 0.03. All right. Now I'm just gonna drag that above because I want this to sit here, 0.125. Actually, 3 millimeters. All right. E for extrude, and we're gonna do symmetrical, then Don't like that. Okay. I don't think it's that bad. We'll see how that goes. Okay, great. So, do a sketch here. All right, this guy is roughly 6.5 inches. So I'm going to project this line because I want to be collinear with the bottom of the base. And then project this to do a parallel. I like that. I like that. Okay. All right. Sketch, make a flange. 1.75. Ah, okay, my bad. Symmetrical side 2. Flange this. Again, this is roughly 2 inches. And flange again. I love working with sheet metal or patterns. They're really easy to work with, and everything is made of sheet metal. Insane. So we'll do a 2 again. We have to fix this here. Rotate that. And then our face outside. Well, inside. Jason outside. Inside. I don't know all the settings that well for this guy. In this case, I'm gonna go fix a sketch and delete that flange. Delete that. I made a mistake on there. There we go. Here, like that. Two. All right. Here's the fun part. We're gonna get into some of the characterization. But first, we're gonna make little tabs. That's about two inches up from the base. Huh. Lost my little sticker. That's fine. And how big are these? Half an inch. And again, 3/4. Mirror this. Some of this is not very entertaining, I know, but I should be setting a timer. Yeah, let's time this. Okay. Finish. Extrude. Well, I think it's just flange. Yeah, flange, flange. Side two. Nice. There, and then flange this. Flange that. 125. Alright, now Okay, 5 minutes. We're gonna take a little break soon once I finish getting the eye down, because I just wanna get something that looks okay. Let's see how this looks. Oh, no, it's not gonna work. Yeah. Let's see. I2. And then show the sketch here. Extrude cut. What? That's not fair. Wow. Okay. That's not fair. All right, so again, here's another thing with Onshape versus Autodesk when it comes to, so this didn't even flange, it's just a random part, and it doesn't give you an option to combine with the body. It doesn't give you an option to combine with the body. So what I need to do instead is hide this, and then I'm going to change this flange to an extrude. So we're gonna roll back here, and then do an extrude so that I have a proper flat pattern. Extrude that, join, and then joining with this. So -3 millimeters. Well, yeah, no, I'm not even going to do that. I'm going to do to body, to object, and then pick the back, and then I'm able to join. So now I have that working. This is going to delete this, or delete that, delete that. Okay, now it's one body. So let's see if this flat pattern works. Create flat pattern. Contains body select. That select already contains a flat pattern. Okay. Activate. So I have this flat pattern. Finish. Hide that. Hide that. Create flat pattern. The component that contains the selected body already contains a flat pattern. The component can only contain one flat pattern. Sheet metal bodies need to be separate components. Okay, I had this workaround here too. I came across this online where having multiple flat patterns is a no-no in Fusion 360. So what I need to do to cheat it, pretty sure. So I'm just gonna do this, you know, to body, there, join, and then do 2 flanges. 1.75. 1.25. Okay. So now that I have one body, I'm gonna fast forward here so that I have the full thing. So now that I have my basic thing. Okay. Yeah, delete that. Yes. Okay. Delete that. I'm just gonna go. Okay. No, I don't like that. 0.1. Okay, so what I need to do here to get the flat pattern correct is create a new component. Right. create components from body. Not operate for sheet metal body installation. Cannot be used for this operation. Okay. Okay. I know I fixed this. It's body. Yeah. Okay, I need to duplicate it. I duplicate the component. Select that. Move type, translate, capture position, cancel. Okay. Modify, move copy. Translate. I'm just going to translate on my 03. Negative. And then create a copy. Object. All right, we're going to take a 5-minute break and I'll get back to you. This is learning Autodesk Fusion 360. Whereas, you know, here's an example. Or before I take a break, I'll show you a quick example on how easy it is to make something in Onshape. Alright, so in Onshape, simple, right? We go here, well, and there, all right? So, create a sketch. Boom, boom, boom. D4, because I use this every single day at work, which is nice. Right. Then, oh, yeah. Create sheet metal, extrude, boom, boom. And then, good thing with Onshape is you could do it symmetrically. Alright. Symmetric actually makes it 2. Thickness 3 millimeters, sure. Alright. Now, I automatically have a sheet metal part. Right there. There's a DXF. I can export the DXF whenever I want. Alright, no problem. And then I just make another one. Sketch. Alright. sheet metal, extrude, and then I have 2 parts. All right, and they're both independent of each other in the same document. How is it's that easy, right? So now in Onshape you have 2 sheet metal parts right in the same space. Thank you, Onshape. Tisk tisk, Autodesk. So I'll be back. I have to figure out how to fix this because I did it before, but to have 2 sheet metal parts in the same document is a no-no for Fusion 360. So we'll be back. Okay. So okay, so I figured out how to get multiple parts into Fusion 360 as sheet metal patterns. I remembered back a while ago, there was this gentleman, John Hackney, who it's basically simple. You have create components from bodies, boundary fill, and convert to sheet metal. So turn that away. I'll add this video in a link to the description. Let's watch the video again.
Maybe you need to add joints to them. Maybe you want a flat pattern. You get the message. The whole bodies again under each components. Or it is. So you say to yourself, wow, I got to go back and create components and create the whole bodies again under each component? No. In this video, I'm going to show you how to convert bodies into components, sheet metal bodies that is, into components without having to go back and start over. To get started, you want to go to the solid menu, create, go down to boundary fill.
Let's try that. Solid. Boundary fill. Alright, that didn't work.
Pick on the tool, and by tool they mean the body that you want to convert. Click on the select button and hit the checkbox to select that. Body. You want to end up with a new component. Now this option is up to you. Whether you need the body for future work, you can also remove it, which I'm going to do. That's totally up to you. It will remove the body and replace it with a component. Say OK. As you can see, we have a new component. The body is there. It's not a sheet metal body now, but it's there. The sketches that created did not come along, but are available in the sketch folder. Since the body is not a sheet metal body at this point, you need to convert it to sheet metal. Activate the component, go to the sheet metal tab, and select convert to sheet metal body.
Nice. We got it. We got it back. All right, great. So what I'm going to do here is finish up the characterization, put some mounting points in, and I think we should be good to go. All right, so we're going to delete this, delete that history. All right, so as we go, right? So from the video, we have to... And let me run through that again. Okay, so from the video, what we do, because as we saw where with Fusion 360, you're able to create multiple sheet metal parts. Oh no, with Onshape, you're able to create multiple sheet metal parts within a assembly or a part studio. This is a part studio, right? But you cannot do that in Fusion 360. So what you have to go through is, as the handy, right, John Hackney explained, you go down, right? We have all this here. We have our body, right? This is technically a sheet metal body, but you can't get a flat pattern from it. So we have to go to solid, the solid tab, then boundary fill, select the boundary, check the box, create a new component. All right, now that we have the component here, we go back to sheet metal and then convert to a flat pattern by selecting the part. But actually, jeez. All right. Convert to sheet metal. There we go. Convert to sheet. Yeah, not create a flat pattern. We convert to sheet metal. Pardon moi. All right. Now we have a sheet metal part, which we could get a flat pattern from right here. All right. So now we have our flat pattern. I could export a DXF and send the file out. All right. But with all that, we basically delete a bunch of space. It looks like we delete all the features. So I'm going to finish building this out. It shouldn't be too long. All right, I'm gonna kind of go through here. Okay, because we want to make ornery ox right there. So we're just going to... One comment I had from someone was that these holes made it look like it had multiple eyes. Don't want to have that. So I'm going to make the part. Give him a nice little mouth. So I did like a little double cut there. Oh, a little mess up there. It's fine. One thing that I distinctly remember when I was first using Fusion is that I would just draw these construction lines constantly. Everything was construction lines. It's just a little laborious, but necessary. Alright, and again, the classic CAD work. Mirror, mirror, mirror. Mirror, mirror on the wall. Who's the fastest CAD of all? That's good. That's fine. And again, so it's nope. All right, that's basically, you know, that's good to go right there. And then I have the stand, which I'm going to do is change this sketch. And I just thought of this as I was doing it, but this is going to be the belly button. So cancel that. So I'm just going to put a screw right there. And then delete these holes. Okay. Putting some materials on that, right? Okay. First thing I'm going to do is fix this to where oh no. Here's another thing, right? So, I'm gonna pause. Onshape, I can change the material. 0.125. Well, it's alright, 0.25. So I have 1/4 inch thick material. And then down here, I have a 3mm material. Seems like I can't do that right away here. So I have 080 for the aluminum, because that's going to be the aluminum. The aluminum is going to be an 080 sheet of aluminum. But I can't do the same for this unless I could change it. Let's see. Let's do a quick save. This is a mess. Bend override. Let's see. Nope. Did not work. All right, let's see if we could cheat here. So I'm gonna try and cheat it with a move face. I don't know if it's gonna work. Man. So let's whip out the calculator. Millimeters, inches, 3.001, 0.1111. 0.301. Ooh, darn blew up. Wow. Can't complete sheet metal due to an internal object, the body, and bend parameters. Yeah. Yeah, I don't know. All right. Yeah. So I switch it all to 3mm. At least I get this flat pattern, so I could change in an assembly. So now I got the most complicated part in 3mm acrylic, and I can change the assembly to be a little bit more forgiving. Ugh. Ugh. It does not look good in Fusion 360. These guys. A lampshade. Ugh. It looks not fun. Ugh. So that's basically the quick concept there, right? File save. I'm gonna throw in a quick light bulb. All right. So, yeah. Like if I have that, that's basically right on the back plane. Alright, I think that's, you know, there's still some work to be done on this. I don't know how I feel. I may cut the mouth out on the sheet metal part. And then in terms of the assembly, I need to put the screws in. And this is kind of what it's going to look like, right? Like, I wish this was a little bit more, you know, refractive index 2. Okay. Quartz. Alright, so something like this. Alright, a little background. I kind of like it. Yep. Perfect timing. Alright, that's gonna take a little break right there. And I'll do a little rendering, see how it goes, you know? Peer out.